Let's take a look at this second problem. Carlos traveled to his friend's house and back. So again, very similar to the first problem. It's a round trip type situation. Let's take a look closer and see what other information we have. It took 1 hour less time to get there than it did to get back. On the average rate, the trip there was 40 kilometers per hour. On the way back was 30. So that makes sense. If you're going faster, you're going to get there in less time. So on the way there, Carlos was in a hurry to get to his friend's house, and then not in a hurry to get back home. So how many hours did the trip there take? So well, let's try to set it up like we did in the first problem, and the distance that Carlos is traveling to his, to his friends is the same distance that he travels, let's just call it home. Now we know that distance is equal to rate times time, so that we can replace this distance with rate times time. And we can do the same over here. But it's in reference to a different rate, a different time. So here, the rate and time we're interested in is when he's going to his friend's house. And here, when he's coming back home again. We saw that to his friend's house he went faster. He went at a rate of 40 kilometers per hour. Coming back home, he went slower. Doesn't say why. 30 kilometers per hour. How many hours did the trip there take? So they want us to find how many hours is the time, and there means to his friend's house. So let's let that be the variable. And it took 1 hour less time to get there. So this was the smaller number, the less time. This is more time to get home because you're going slower. How much more time? It says 1 hour, a 1 hour difference. Alright, so let's see if we can solve this for x. So I'm getting that it took him 3 hours to drive to his friend's house. Which would make it 4 hours to get back home because he went slower. But this is what they wanted. So I hope that helps. Alright, I'll go on to the next one.